All right, now we're going to think about rotating pi over 2 radians around the point 0, 0, clockwise and anti-clockwise, and then more generally with theta. So if we think about making our x and y axes, and then we take some point xy and rotate it by pi over 2. So here's my vector xy. If we rotate by pi over 2, then I've got a 90-degree angle. My slope from this line here is going to be y over x. So I've got my y value, my x value. This slope is going to be negative x over y. So this value is going to be positive, so that's x, and this is going to be negative y. So my coordinates, negative y, x. So that means my transformation matrix for 90 degrees, so I'll call that a right angle anti-clockwise. I'm going to end up with 0, negative 1, and 1, 0. If I do the opposite, if I rotate 90 degrees or pi over 2 clockwise, then I'm going to end up with this line down here. Again, I've got a slope of y over x, so this slope is going to be negative x over y, and here's my negative this time, negative x over y. So transformation of a right angle clockwise, I'm going to end up with 0, 1, and negative 1, 0. All right, but what if I don't rotate pi over 2 radians? What if I just rotate theta? So we're going to start again by thinking of our standard unit vectors. So I'm going to take my picture here. We'll take some point xy. Sorry, we're not going to take some point xy. We're going to take our standard unit vector. So we're going to start with 1, 0 and rotate it theta degrees anti-clockwise. And this is what we generally do, is we rotate anti-clockwise. So in this case, again, I've got a length of 1 here, and now my coordinates are cosine theta and sine theta. So t of 1, 0, so this is going to be a t rotation anti-clockwise. I'll end up with cosine theta, sine theta. And now if I think about taking my standard unit vector 1, 0 and rotating it by theta, well, I can look at this right triangle here. So looking at this right triangle, this side over here is going to be sine theta, and it's going to be negative because I've come into the negative x-axis space, and my height over here is cos theta. So negative sine theta, cos theta. If I repeat this for rotating in the clockwise direction, then I will have 0, 1. Now I'm going to rotate down here. Here's my theta. So I had 1. Now this is my length of 1, so my 0.01 would actually be somewhere around here. Rotate it down. Looking at my triangle here, my cosine value is positive, my sine value is negative. Let's move that over. So this is our transformation rotating clockwise. We've got positive cosine value, negative sine value. And if I take my 0, 1 and rotate it by theta degrees, I still have my length of 1 here. And now this time, this is going to be sine theta, and my height is going to be cos theta. So we applied our standard unit vectors to find our different transformation matrices. This one is the one we'll use most often because we almost always rotate in the the anti-clockwise or counterclockwise direction.